when a metallic surface is illuminated with the radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated with the radiation of wavelength 2 lambda, the stopping potential is V by 4. The threshold wavelength for the metallic surface is. So, Einstein's photoelectric equation only we have to use. So, we usually associate the threshold frequency and kinetic energy, all those things. Here they have given wavelength and stopping potential. We usually associate more the frequency, more is the stopping potential. However, frequency is inversely proportional to wavelength, which should be proportional. So, lesser the wavelength, more is the stopping potential. That is a conclusion we have to get. But however, that is a shortcut. Otherwise, Einstein's photoelectric equation says H nu is equal to H nu naught plus kinetic energy. Now this is Hc by lambda is equal to Hc by lambda naught, which is a threshold wavelength, and we know kinetic energy is the charge of the electron into its stopping potential. Charge of the electron into its stopping potential. So, I will write it as EV in this case. So, this is equation 1. Similarly, the second case is when it is illuminated by wavelength 2 lambda, that is Hc by 2 lambda. This is Hc by lambda. The stopping potential changes to V by 4. This is equation 2. Changes to V by 4. Now, what we have to do is we have to take the difference, and maybe we can take the ratios also. Better if we take the difference. Now, equation 1 implies Hc is common, 1 by lambda minus 1 by lambda naught equal to EV, equation 3. Similarly here, Hc is 1 by 2 lambda minus 1 by lambda naught is EV by 4, equation 4. Now, I can take the ratio of equation 3 by 4. Equation 3 by 4 if I do, Hc cancels. What remains there is 1 by lambda minus 1 by lambda naught divided by 1 by 2 lambda minus 1 by lambda naught, which is equal to E cancels, V by 4. So, that is 4. Now, 1 by lambda minus 1 by lambda naught is 4 into 1 by 2 lambda minus 1 by lambda naught. This turns out to be 2 by lambda minus 4 by lambda naught. This is 1 by lambda minus 1 by lambda naught. So, I will rearrange this. 4 by lambda naught minus 1 by lambda naught is equal to 2 by lambda minus 1 by lambda. 1 by lambda. So, the relation that we need to get, lambda naught is a common denominator, 4 minus 1. Here lambda is a common denominator, 2 minus 1. So, 3 by lambda naught is 1 by lambda, implies lambda naught is 3 lambda. So, the threshold wavelength is 3 lambda. So, option B is the right option. Option B is the right option.